Hi everyone. In this video, I want to actually solve some problems. So this video is going to be a supplement to the previous video, video 5. So if you want to go over some concepts that will be presented in this video, please watch the previous video before watching this one. So let's start off with problem 1 here. So we're given the angle 1, which is angle ACB is congruent to angle 4 CBD, and that angle 2 BCD is congruent to angle 3 CBA. What can we conclude from this? So let's set up this kind of like facts and reasons kind of way of proving things over here. And first we write down what we're given. Angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. And we know from the previous video that when we have these two types of congruence, when we have this type of congruence equivalence, we can actually add these two together to get kind of a larger congruence relation. So angle 1 plus angle 2 is congruent to angle 4 plus angle 3, which is the addition property of congruence. So let's look at what angle 1 and angle 2 are. Angle 1 plus angle 2 is going to give this larger angle ACD. So I just substitute this angle 1 plus angle 2 with angle ACD. And then similarly, angle 4 plus angle 3 is going to be this angle ABD. So we get the congruence ACD is congruent to angle ABD. So this is an important property we'll see later on when we go into detail about properties of quadrilaterals and parallelograms and rectangles and things like that. In a parallelogram, opposite angles are always congruent. So ACD is congruent to ABD, and also angle CAB is going to be congruent to CDB. But we'll go over that later on. So just kind of look over, the addition property of congruence and see how it applies to this problem. Let's move on to a second problem. So here, segment AB is congruent to segment AC, and segment AD, this bigger one here, is congruent to segment AE, this bigger segment over here. So what can we conclude from that? So, like in the previous problem, we write down what we're given. Segment AB is congruent to segment AC, and segment AD is congruent to segment AE. And then we're going to actually subtract segment AB from segment AD. So just do it like we're subtracting these two congruences here. So on this side, we get segment AE minus segment AC, and this is the subtraction property of congruence. So what is segment AD minus segment AB? Well, if we subtract this section here from the whole segment, we're left with segment BD. And in the same way, if we take off segment AC from segment AE, we're left with segment CE. So we can write segment BD is congruent to segment CE. So take a look at this problem, go over it a little bit, and try to understand what's going on. Again, this is kind of like a basic example of how properties of congruences are applied to problems. Let's go over this problem here. So we're given that angle ABM is congruent to angle CBN. What can we conclude from this? So we write down what we're given. Angle ABM is congruent to angle CBN. And I know we didn't really talk about this, but there's additional property of congruence, which is the reflexive property of congruence. So something is always um, congruent to itself. So this is pretty self-explanatory. Angle MBN is congruent to itself. So we'll just write that down here, and I can write down the reason: reflexive property of congruence. So when we have these two congruences here, let's add them together to get angle ABM plus angle MBN is congruent to angle CBN plus angle MBM. So this is the addition property of congruence. And then we take a look at what this represents. Angle ABM plus MBN is going to be angle ABN. And then on the right side, angle CBN plus angle MBN is going to be this angle CBM by substitution. So for the final problem, I want to actually go over, we actually solved this problem, not in the last video, but I think the video before that. And I want to show you a different way to solve this same problem here. So in math, there's often more than one way to solve a problem. So this is kind of a good example of this property. Let's take a look at what this problem is. It's we're given that segment AB is perpendicular to segment AD, and that segment AC is perpendicular to segment AE, and we need to prove that angle 1 is congruent to angle 3. So as always, write down what we're given, these two statements here. And since perpendicular segments meet at right angles, so if AB is perpendicular to AD, then let's see, if AB is perpendicular to AD, then BAD angle, that angle is going to be a right angle. And since segment AC is perpendicular to segment AE, then angle CAE is a right angle. So we know from properties of congruence that all right angles are congruent. So angle BAD is congruent to CAE. And right angles are congruent. Why? Because all right angles measure 90 degrees. So the measure of right angles is always going to be the same. So we just use the definition of congruence to kind of establish this property for right angles. Again, I'm using this reflexive property of congruence, which is pretty straightforward. Angle 2 is congruent to itself. And now, using these two congruences here, if I take the bigger angle, which is BAD, and I take off angle 2, so we subtract these two quantities here, and if I do the same with CAE minus angle 2, we're left with angle 1 is congruent to angle 3. So kind of look at this figure here and try to understand what's going on. Like I said, I solved this problem before, but I used some different properties of congruence. So just kind of look it over and actually see if you can do both the same problem in two different ways, like I did it here. And that wraps it up for today. So thanks again for watching, and be make sure that you watch the previous video to this one to kind of get a better idea of some of the properties that I went over. Okay, have a good night, guys. Take care. Bye.